Hello everyone. Today we'll discuss about the venturimeter and its derivation, its application, its advantages, disadvantages. First, I Samresh Pratap Mahanti, Assistant Professor, Department of Mechanical Engineering at Vedang Institute of Technology. So start the process venturimeter. The topic venturimeter. This is a simple venturimeter diagram. It consists of three parts: inlet, throat and exit, which is known as outlet. In this converging zone, the velocity accelerates, and in the diverging zone, the velocity decelerates. D1, D2 is your diameter, Z1 is your pressure energy at particular datum line, and now let start the expression. First, we already know that what is a venturimeter? Venturimeter is a flow measuring instrument. It is the application of Bernoulli's theorem. Okay, let's start the derivation. In previous diagram, the D1, D2 are diameter of inlet and throat. Diameter of inlet and throat. Diameter of inlet and throat. P1, P2, pressure of inlet and throat, V1, V2, velocity, now comes to expression. We know that Bernoulli's theorem states that what? The sum of kinetic energy, potential energy and pressure energy is equals to constant. So for these two sections, your sum of kinetic energy at section 1, potential energy and your pressure energy is equals to, at a particular point at the section 1, is equals to the sum of energy at section 2. Plus Z2. This venturimeter is horizontal venturimeter. Okay, so Z1 is equals to Z2. Now Z1 is equals to Z2 for horizontal venturimeter. For this venturimeter, Z1 is equals to Z2. Now equation 1 reduces to, now your equation 1 reduces to P1 by rho g minus P2 by rho g is equals to, can Z2, as Z1 is equals to Z2, so cancelling these two, V2 square by 2g minus V1 square by 2g. Now P1 minus P2 by rho g is equals to V2 square minus V1 square divided by 2g. Considering this term is equals to h. This is the equation 2. Now your V2 square minus V1 square divided by 2g is equals to h. We consider it. Then that implies that your V2 square minus V1 square is equals to 2gh. We know that your discharge Q is equals to A1 V1 is equals to A2 V2 at particular point of section 1 and section 2. Now Q is equals to A1 V1 is equals to A2 V2. Now your V1 is equals to A2 V2 divided by A1. This is the value of V1. Now V2 square, putting this value V2 square in equation 3, putting the value of V1 in equation 3, V2 square minus your V1 value is equals to A2 V2 divided by A1 square is equals to 2GH. That implies that V2 square minus A2 square V2 square divided by A1 square is equals to 2GH. Now V2 square is equals to your common factor. So by taking common A2 square 1 minus A2 square divided by A1 square is equals to 2GH. V2 square taking common 1 minus A2 square divided by A1 square is equals to 2GH. Now taking LCM, V2 square A1 square minus of A2 square divided by A1 square is equals to 2GH. Now V2 square is equals to 2GH divided by A1 square minus A2 square divided by A1 square. Now by simplifying this, 2GH A1 square divided by A1 square minus A2 square. Now for V2 square value is equals to that much, we have to finding the value of V2. Okay, then taking root over, V2 is equals to 2GH root over of 2GH. Your root over of A1 square is equals to A1. Now A1 square minus A2 square root over. V2 is equals to this much is equals to, now putting the values, as we know that Q is equals to A2 V2, putting the values of V2 in above equation. This is the value of V2. Okay, this is the value of V2. A2 V2 value is equals to your A1 into root over of 2GH divided by A1 square minus A2 square root over. This is the value of your discharge. Now this is Q is equals to coefficient of discharge. This is your Q actual is equals to CD discharge coefficient, and this value is equals to your Q theoretical. So Q actual is equals to CD into Q theoretical value. For short, we also write that Q actual divided by Q theoretical is equals to CD, and this value CD is your coefficient of discharge, and this value never exceed 1. Okay, never exceed 1. Now this is the required expression for a venturimeter discharge. Now comes to the topic that what types of venturimeter are the venturimeter is three types. First, horizontal, vertical, and your inclined. In horizontal venturimeter, your kinetic energy is maximum, whereas the potential energy is minimum. But in vertical, the kinetic energy is minimum, whereas the potential energy is maximum. But in the case of inclined venturimeter, in this both are equivalent. Okay. Then comes to the application of venturimeter. It has a wide range of application in automobile industry, in pipeline sector, in processing industries, in medical industry, everywhere, in chemical processing plant, everywhere there is the application of venturimeter. Okay. Then comes to the what is the advantages and disadvantages of venturimeter. Advantages. First, your no moving part. Your second, less energy loss. Less or low energy loss. Result is accurate. Result we find is accurate. Coefficient of discharge, your CD, coefficient of discharge is high. Your low pressure drop. This is the advantages. And comes to the disadvantages. Disadvantages is it occupy more space. Cost is high. It is not used for small. Small instrument. And these are the disadvantages. These are the advantages. And then also we know that the types, three types. Already I told, but I mention in this. Horizontal, vertical, and inclined. Already I discussed about this, but I mentioned in this slide. Inclined one. So this is all about the venturimeter, its expression, its application, its advantages, its disadvantages, and its types. See previous slide. This is the required expression. Clearly visible. It is clearly visible, and this is the clear expression for the venturimeter. Okay. So in the next class, we will do some problem about venturimeter, regarding the venturimeter. So wait for next video. Thank you.